Good day, everyone. We are Team 16, and we are about to present to you our final project called SWE-lutions. Well, first of all, here's our development team. First of all, we have Emma Alfaro, who was mainly in charge of the multi-agents proposal. Me, Fernando, who was mainly in charge of developing the fine-tuning model. And Omar Macias was in charge of the architecture of the proposed solution. Carlos was providing help in every single of the areas. And Alexis Garcia, who was mainly in part of the syntax analysis. Here's our agenda, and we're going to start with the differentiator of our project.
So what makes our project different from others is we decided to implement a multi-step AI processing. How this works is we implemented a multi-agent communication, and basically this begins with an analyzer agent. This agent receives a GitHub URL with the GitHub issue, and what it does is extract all of the information he can from the repository to convert it into a JSON file. In this file, we're going to find the problem description, first guess, file path, and all of this is going to be sent to another agent that contains the SWE agent tool. Here in this agent is gonna receive the JSON file and is gonna process all of the information that the analyzer gave him. And after this, it's gonna generate a patch that might resolve the issue. And after the patch is generated, it's gonna send the patch to a third agent, which is called the reviser. And this reviser is gonna approve the patch or don't approve. And if it doesn't, it's gonna go back to the SWE agent in order to make a different patch.
Talking about the architecture and mainly the design behind it, we have, as Emma was saying, first of all, the user gives or calls this tool with the with the GitHub issue URL. And first of all, we gather that part around, and we have like this other script that contains all the agents, and that calls the analyzer tool that fetches and retrieves the relevant information, files, and directories on the whole tree of the GitHub repository. Then it's continually processing it with GPT-4o until it has a first guess, the problem statement, the file path, the paradigm, and also we pass the issue URL to call the agent with all of that information. The SWE agent calls the tool SWE agent, and from there it also fetches GitHub and all of that. It's processing, and after all of that part and all the steps that the SWE agent has to run, we come up with a patch. You have a revisor tool and the agent that iterates through that solution given the whole idea, problem statement, and files to say like it looks good to me or if it needs a fix. Basically, we replicate the idea of a development team where we have this PM or manager that gives you the best looking approach or even just the best description of the problem. We have this junior, let's say, agent that is the SWE agent that comes up with a PR, and we have the revisor one that basically makes a PR revision and approves or don't. And if don't, we iterate through this with the SWE agent again until we have an approved patch.
Well, now talking about our key findings, we have four four biggest key findings. First of all, regarding the open source models, we concluded that they are considerably limited when compared to some commercial LLMs, such as GPT-4, GPT-4o. Also, regarding the current AI state of art, we found out, or we sort of find out that these systems can solve human-like problems, but they do have to they need the right context and capacity to solve them appropriately or and effectively. Also, regarding our scope, the multi-agent frameworks, this scope allowed us for more efficient problem solving and more capability to split the tasks that before were done by just a single agent, leading us to better results. And finally, regarding the fine-tuning techniques, we found out that customizing AI models according to our needs by fine-tuning made the AI system or the LLM behave more accordingly to our particular scope and follow our guidelines. And now, talking about briefly about our tech stack summary. First of all, we used Hugging Face to retrieve and upload our models, our fine-tuned models. We use AutoGen for the multi-agent part. Of course, we use SWE-agent because it's like the cornerstone or the pillar stone for the project. We used the datasets from SWE-bench to solve real-life GitHub issues and try to make our proposal look more real-life applied. For Onslaught was in charge of performing the fine-tuning of our models. We use also Docker to run the agents on, for example, in run batch mode. Model was in charge of being the place where we would host the model and provide us an API endpoint to call the model whenever this agent needed. And the models that the first model that we tried to use was Depstral, but we also used models, commercial models such as GPT-4o.
After all, we find out that DevStraw was giving a couple issues, even though that it had been working properly for us along the project and for a couple weeks actually. But the day before the presentation with C3, DevStraw started failing, and that also affected our fine-tuned DevStraw. But we were able to test some test cases of the SWE-bench dataset that are really real world issues. For example, in this case, from Django or from SciPy, and it was able to solve 60% of those. And we also tested with GPT-4o, and it actually gave a better result, which was around 80% of these solve.
So I'm gonna explain a little bit about our demo. Basically, what happens first is we are getting our GitHub URL with the issue, and here's where our analyzer agent is gonna start processing the issue through the URL, and here's our analyzer result. The JSON file with the problem statement, the GitHub URL, first guess, and file path. After this, this information is passed to the SWE agent, and here is the SWE agent starting the process of fixing the issue. Um, After the SWE agent finishes iterating and creates a proper patch to fix the issue, we deliver the patch to the revisor agent, and the revisor agent approves, and that is it. Thank you.